So we had a question come up from a customer about chemical salts. So this is quite a common question we get because of my chemistry background. I usually get fielded with most of these. So remember, when we're measuring gases coming from a process, as we extract them out of the process and bring them down to the analyzer, there's lots of different chemical reactions that can take place. Remember from previous videos, every chemical reaction requires time, temperature, and some sort of agitation or movement. So anytime we have a pump, piston style pump with a negative and positive stroke, that creates agitation. Whenever we change the temperature, we can have formation of chemical salts. And sometimes, simply by the amount of time it takes to draw a sample out, down to the analyzer, there's still chemical reactions that are taking place in that gas normally that are still transpiring. Quite common one is, customer calls up and says, I've got a chemical salt forming in my chiller. And why it's so critical at the chiller is because it's the point at which, if you're using a heated probe, heated sample line, the chiller is the first point where that gas starts to cool down. So common chemical salts that form, if it's white, will usually be ammonium chloride. If it's a little bit yellowish, it can be ammonia sulfide. And there can be lots of variations depending on other minerals that could be in the gas stream. If you have metals like iron or copper, you can get different discolorations of that chemical salt. The key to it is we've had some customers say, oh, I think this is actually particulate. They think it's a hydrocarbon-based product. But it's quite simple. Take your chiller, take that chemical salt that's formed, take a little bit of water in a lab squeeze bottle, squirt the water in there. If it instantly dissolves, it's a chloride base. And so if it's chloride base, it just means you need to regulate your temperature or your flow rate better so that that salt, which will form, you won't stop the chemistry, but all we do is try and control where it takes place. You want that chemical salt to form inside the chiller so that it's also where you're starting to condense liquid, because that condensing liquid will now cause the chloride or the ammonium chloride or ammonia sulfide to actually break down, turn back into a liquid and dissolve and roll right out. And it's never a problem. It's only a problem where you have it condensed out in too long of a stretch of a sample line before the chiller or right at the front neck of the chiller. The only time you have to worry is when you squirt hot water on it and it doesn't dissolve. That's when you can start looking at whether it's a hydrocarbon-based product, which is usually black because it's a tar, petrochemical-based product, or if it's actually granular or gritty and you actually retain it, it doesn't break down, it stays there, or it just breaks down and doesn't dissolve. You can still see the grit in the bottom of the glassware. Then you could actually be dealing with an actual piece of particulate. If you're forming particulate, then it means that your probe's not doing the right job of filtering.